A crane lifts a car vertically. The car is inside a crate, which is raised by a crane by means of a strong cable. The cable can withstand a maximum tension of 9,800 newtons without breaking. The crate has a mass of 60 kilograms and the car has a mass of 850 kilograms. Find the maximum acceleration which the crate and the car can be raised. Draw two separate clearly labelled diagrams showing the forces acting on the crane and the forces acting on the car while in motion, and determine the magnitude of the reaction force between the crate and the car when they are ascending with maximum acceleration. Now this is very similar to a man in the lift problem. Okay, so first step, drawing the diagram. Now what you need to do though is treat the car and the crate as just one object. This is like a connected object. So you're going to have the crate and you're going to have an upwards force of tension which is 9,800 newtons. The combined weight of the man and of the car and the crate is going to be 910 G newtons. And then we're going to have an acceleration going upwards, which we're going to have to calculate. And then resolving vertically, we're going to have 9,800 minus 9,010 G is equal to 910 times A. Rearranging for A, we're going to have 9,800 minus 910 G divided by 910. Don't cancel like that because it's a common denominator. That gives A being 0.96923, which is 0.969 meters per second to free figures, but more useful would be to press the S to D button on your calculator and get a fraction 63 over 65 meters per second squared so that we can use it again. Right. If we now got the crate, and we draw the diagram. So on the crate, we've got the maximum tension, which is 9,800 newtons. We've got the weight of the crate itself, 60 G newtons. And then we have the reaction of the car on the crate, which we're going to call R. You should try to avoid writing down the actual weight of the car in this sort of problem. And then you've got an acceleration upwards, which is 63 over 65 meters per second squared. Notice I used a fraction, so that will avoid me making a rounding error. Then if you draw the car separately, and it's a good idea to do this even if you're not asked to, the weight of the car is 850 grams, 850 G newtons, not grams. And then we've got the same normal reaction as this one going upwards, of the lift on the of the crate on the car. Right, again the same acceleration. Right, if we consider the car because it's the easiest, we can say that R minus 850 G is equal to 850 times 63 over 65, and they've got R is equal to 850 times 63 over 65 plus 850 G. And that gives an answer of 9,153.84 newtons, which rounded to three significant figures is 9,150 newtons. Now, if we've done this correctly, this R here should be the same for the crate, so you could use one to check against the other. So we're going to have 9,800 going upwards. Downwards, we're going to take 60G and R, and that would be the 60 times the acceleration, which is 63 over 65. Rearranging for R would give 9,800 minus 60G minus 60 times 63 over 65, which again gives the same answer rounded off to three significant figures as 9,150 newtons. Okay, this has been a video to show how to find the normal reaction of a car in a crane being lifted. I hope you've understood, and I thank you very much for watching.